Dear students, good evening. Myself, Dr. P. Dravidamani, professor from Safety and Fire Engineering Department. So today I am going to discuss reciprocating pump with the help of PPT. So let us move to the presentation. So the today topic is reciprocating pump. Before that, what is use of pump? Pump is a device which is used to pump the water from lower level to higher level, or lower level head to higher level head, high head, low head to high head. This is the main function of pump. Is a device which is used to pump the water from lower head to higher head. So this is the main function of pump. So here pumps are used to increase the energy level of the water, by virtue of which it is can be raised to a higher level. Reservoir pumps are positive displacement pump, that is initially a small quantity of liquid is taken into the chamber and is physically displaced and forced out with the pressure by moving mechanical elements. The use of reciprocating pumps is being limited these days and being replaced by centrifugal pumps. For industrial purposes, they have become obsolete due to their high initial and maintenance costs as compared to the centrifugal pumps. Small hand-operated pumps are still in use that include well pumps, etc. These are also useful where high heads are required with small discharge as oil drilling operations. What are the main components of reciprocating pumps? The reciprocating pumps consist of a plunger or a piston that moves forward and backward inside a cylinder with the help of a connecting rod and crank. The crank is rotated by an external source of power. The cylinder is connected to the sump by a suction pipe and to the delivery tank by a delivery pipe. At the cylinder ends of these pipes, non-return valves are provided. A non-return valve allows the liquid to pass in only one direction. Through suction valve, liquid can only be admitted into the cylinder, and through the delivery valves, liquid can only be discharged into the delivery pipe. This is a single acting reciprocating pump. Here the one side the piston moves slide inside the cylinder, so the water, this is a suction pipe and delivery pipe. What are the components? There is a suction pipe, delivery pipe, delivery valve, piston, cylinder arrangements, sump. Okay, this is a single acting. This picture shows the single acting delivery pump. The working of reciprocating pump: when the piston moves from the left to right, a suction pressure is provided in the cylinder. If the pump is started for the first time or after a long period, air from the suction pipe is sucked during the suction stroke while the delivery valve is closed. Liquid rises into the suction pipe by a small height due to atmospheric pressure on the sump liquid. During the delivery stroke, air in the cylinder is pushed out into the delivery pipe by the thrust of the piston while the suction valve is closed. When all the air from the suction pipe has been exhausted, the liquid from the sump is able to rise and enter to the cylinder. During the delivery stroke, it is displaced into the delivery pipe. Thus, the liquid is delivered into delivery tank intermittently. That is during the delivery stroke only. So, what are the classification reciprocating pump? So, it is based on according to the use of piston sides. There is a single acting and double acting pump. Based on this is a single acting reciprocating pump. This figure shows this power is taken from both sides. So another one, according to number of cylinder, based on the number of cylinders, there is single cylinder, double cylinder reciprocating pump. Based on the number of triple cylinder, single cylinder, double cylinder, and triple cylinder. Based on the cylinder, there is a classification reciprocating pump. So according to the number of cylinder, there is a single cylinder, there is a double cylinder, third one triple cylinders. So here discharge through a reciprocating pump, that is here theoretical discharge equal to A into L into N by 60. This is a simple formula for using for finding the discharge through a reciprocating pump. This area of the cylinder, there is a discharge. How to find out the discharge? So thus the discharge of a double acting reciprocating pump is twice than that of the single reciprocating pump. Owing to leakage losses and a time delay in closing the valves, actual discharge usually lesser than the theoretical discharge. So what is the slip? Slip is the major role in the reciprocating pump. What is the slip of the reciprocating pump? Slip of his reciprocating pump is defined as the difference between the theoretical discharge and actual discharge. Slip equal to theoretical discharge minus actual discharge. Therefore, Q theoretical minus Q actuals. The percentage of slip is equal to Q theoretical minus Q actual divided by Q theoretical into 100. So by using this formula, we can find out the slip of the reciprocating pump. Slip where CD is known as coefficient of discharge and is defined the ratio of actual discharge to the theoretical discharge. Therefore, coefficient of discharge CD equal to Q actual by Q theoretical. So, what is the negative slips? It is not always that the actual discharge is less than the theoretical discharge. So, in case of a reciprocating pump with a long suction pipe, short delivery pipe and running at high speed, inertia force in the suction pipe becomes large as compared to the pressure force on the outside of the delivery valve. This opens the delivery valve even before the piston has completed its suction strokes. The sum of the water is pushed into delivery pipe before the delivery stroke is actually commenced. This way the actual discharge becomes more than the theoretical discharge. Thus the coefficient of discharge increases from 1 into 1 and the slip becomes negative. The power, how to calculate the power? By using this reciprocating pump. Here power input to the pump rho into ALN by 60 into G into HS plus HD. So here the simple formula for finding the theoretical discharge, actual discharge, slip of the pump and power required to running to drive the pump. So this problem we will see the next video. Thank you.